Welcome back to our lecture series on linear control system. So this is the 5th lecture of module 1, and today we are discussing about Mason's gain formula. So this is somewhat related to the signal flow graph of a process. That is, a process means, as you all know, it is some physical phenomena that we can model by using mathematical equation also. For example, if you are considering a process with 5 steps, each process converts one input to another input. After the first stage, the second process converts the first stage's output to another output. That second stage output is fed as input to the third stage. So such a step-by-step arrangement is represented in signal flow graphs. Okay, anyhow, we are directly coming to signal flow graph. So what is the connection between signal flow graph and Mason's gain formula? Mason's gain formula is used to find the overall gain or transfer function, that is output by input, of a signal flow graph. So before going to Mason's gain formula, we should be aware about the signal flow graph. So anyhow, all such processes can be modeled by using mathematical equation. So I have given a 3 equation, x2, x3, x4, and we are asked to draw the signal flow graph of the system described by these equations. Okay, draw the signal flow graph of the system described by these equations. So x2 is equal to a12 into x1 plus a32 into x3, and similarly 3 different equations are given, and below that you can see x1, x2, x3 are called as nodes or variables, and a11, a11, a12, etc. are known as branch gains or path gains. It is not there in the slide. Actually, it is covered by the watermark of tab scanner. Okay. Anyhow, we are going to realize these equations. So x2 is a suppose this is a process, and I am giving some input here. It will give some output here. Is it clear? Say it is a pen. So it is giving some output here. Okay. So here I can say x1 is this stage or the input given in this stage, and x2 is the output obtained at this stage. So if we are varying the input x1, correspondingly x2 will also vary, and a12 may be the process gain what the system is doing. So the system is converting input to some output response. So that gain is denoted by a12. So in this equation we can see x2 here it is. Okay. Okay. x2 is a12 x1 plus a32 x3. So x2 is a stage output that depending on x1 node and x3 node. So a12 is, I already explained, a12 is the gain of that particular process that is converting x1 to x2. So a12 is the gain of that particular path between 1 and 2, stage 1 and 2. and A3 to X3. A3 to X3 is, there is also X2 is depending also X3. So some feedback is given from X3 to X2. So on the same way we have to analyze the three equation and we have to represent this in a graph. Actually this topic is not that much important. Signal flow graph is not that much important for you. You are oftenly asked to find some gain or transfer function using Mason's gain formula. But without having some in-depth knowledge of signal flow graph, you can do the problems related to Mason's gain formula. That's why we are discussing this thing in detail. Okay, so now let me first draw the signal flow graph corresponding to first equation. So x2 is equal to a1 to x1. Okay, anyhow, it is clear that there is x1, x2, x3, x4. 4 stages are there. First equation describes about stage x2, where x1 is also an input for x2. So x1 is there, x2 is there, and second equation x3 and third equation x4. So these 4 nodes are there. Okay, so initially I drawn 4 nodes x1, x2, x3, x4, and a11, a12, etc. are the branch gains that we already know. Now I am going to draw the first equation. What was the first equation? Now it will be clear. You know that first equation x2 is equal to what was that? a12 into x1 plus a32 into x3. So from x2 you are drawing a line from x1 to x2. That is actually the process, and the gain of that process is a12. So a12 into x2, that is the input, and the particular output is x2. And also here there is a feedback, that is x3 into a32, that is also equal to x2. So we can say x2 is equal to x1 into a12 plus a32 into x3. So these are the two portions that both portions are depending on x2. And also you have to be very careful about the direction of arrow marks. Okay. Now what is the second equation? It is about x3. x3 is equal to a23 x2 plus a43 x4. So you know that first term a23 into x2 means we are transferring x2 to x3 through a gain of a23. So the gain of a23 into the input x2 will give x3. That is the first portion. a23 gain into the input x2 will give x3. And also there is another part, that is relation of x3 with x4, and there is also gain a43. So just similar as the previous, there is two portions. One is x3 depends on previous stage, that is x2 into some gain a23, and x4 also depends on x3, that is a feedback. So we have to draw a gain between 4 and 3, and arrow mark should be directed towards 3 because you are writing the equation of x3. So I am drawing this like, okay, here you can see this is x3. x3 is equal to, you have to check which are the arrow marks coming into x3. First one is a23. From where a23 is coming? From x2. So this equation is a23 into x2 is equal to x3, and also x3 is depending on x4. x4 into a43, that is also equal to x3. So by combining these two, we can say x3 is equal to a23 into x2 plus a43 into x4. Okay. And this is the last equation, that is equation of x4, and x4 is equal to a34 x3, that is just x4 depends on previous stage x3 and gain between x3 and x4 is a34. That is a simple case, and here there is some other term, that a24 into x2. So x4 not only depends on x3 but it also depends on x2. It's one previous x4's previous stage is x3 and it also depends on the last stage, or that is x2. So we have to draw a diagram, draw a line from x2 to x4, and arrow mark should be from 2 to 4, and the gain of that path is a24. Okay, and there is one more last equation, last portion of equation is here. We will tell about that also. So this is the equation of x4. You can see this is the node x4, this is the node x4. You can now check all the arrow marks coming into x4. First one is from x3 to x4, that is x3 into a34, and there is one more arrow mark coming from x2 and gain of that path is a24. a24 means gain between path node 2 and node 4. So x2 into a24, and also there is one more portion in the equation, that is a4 for x4. What is a4 for x4? Because x4 is also depending on x4 and it doesn't depend on some other node. x4 is depending on x4 itself. So what will be the gain? If x4 is depending on x2, you will say gain is a24. If x4 is depending on x3, you will say the gain is a34. But here x4 is depends on x4 itself. So what will be the gain? The gain will be a44, because gain of fourth node based on that node itself, that is a44. So its drawing is very interesting. So x4 is equal to last portion x4 into a44. So it is a self loop, x4 into a44. Anyhow, in exams you will be given such a signal flow graph, and then they will tell you to apply Mason's gain formula. So if the portion I have already explained is somewhat difficult for you, please leave it, because it is not that much important. But I think before entering to this, you should know what is gain, what is node. So for that I have explained this, and how this signal flow graph is obtained. It is obtained from some linear mathematical equations. That knowledge is also important. Anyhow, now you are having a signal flow graph with 4 nodes, x1, x2, x3, x4, and path gains. For example, what is the path gain between path node 2 and 4? Simply we can say node 2 and 4, so 24, a24. What is the gain between node 3 and 4? Everybody please, what is the gain between node 3 and 4? It is a34. So if we are considering only that gain, you can say x4 is equal to x3 into a34. So I am repeating once more. Everybody please listen. What is the equation of x3 from this signal flow graph? So you have to check which are the arrow marks coming towards x3. One is this, x2 into a23, and there is also one more arrow mark coming from x4, and that is equal to x4 into a43. So the total equation of x3 is equal to x2 into a2 tree plus x4 into a4 tree. So this is the case. This is the basic knowledge that you may require to solve some problems on signal flow graph. Now x1, x2, x3 are called as nodes or variables, and a1, a2, etc. are known as branch gains. This is already explained. Now here you can see I am extending the node 4 to a new node that is also named as x4, and gain of that path is just 1. Because why it is just 1? Previously it was x4 and now I am extending it to a new point that is also x4. So there is no change between these stages. So we can say gain is 1. That is, x1 and x2 are two different stages. There is a process between these two stages, and the gain of that process is a12. Like that, if x4 is extended as some other node and that is also named as x4 with same value, then the gain between these two nodes will be 1. So why I have marked x4 like this? That is an important thing that we may see in the next slide. So x1 is the input node. That is very clear, because you can write an equation of x1, because from x1 all the processes are leaving towards outside. So it is a input node. We can say it as an input node. Okay. Input node is a node having only outgoing branches. You have to add only, it is missing. Input node is a node having outgoing branches only. So in this figure, except x1, x2, x3, x4, all are having incoming branches. So they are not input node. Input node is a node having outgoing branches only. What is output node? It is a node having only incoming branches. Any non-output branches can be converted to an output branch by connecting a branch gain of unity. So except x1, all nodes can be converted as output node. This is the case. So output node should have only incoming nodes or only incoming branches. In this figure we can say, please take x2. x2 is having one incoming branch from x1 and one incoming branch from x3. But it is also having a outgoing branch, that is a24. So we cannot say x2 is a output branch, because it is having a leaving branch also. So it is not an output node. x3 also, x4 also. Presently x2, x3, x4, all the three nodes are not a perfect output node. So in order to make it an output node, I am extending x4 to a new point and marking a gain of 1. Now you can see for the new x4, it is having only incoming branches. No outgoing branches are connected with that x4. So it is not only applicable for x4. You can also make x3 as an output node. You can also make x2 as an output node. But x1 cannot be made as an output node, because it is a pure input node that is having outgoing branches connected to it. Okay. So output node is, it is a node having only incoming branches. Any non-output branches can be converted to an output branch by connecting a branch gain of unity. So except x1, all nodes can be converted as output nodes. So here I am converting x4 as an output node, and x1 is already given as an input node. It is a perfect input node. Now forward path. A path which starts at the input node and terminates at the output node along which no node is traveled more than once. This is the definition of a forward path. So all the forward path should start from input node and should end at the output node. In our case, x1 is the input node and x4 is the output node. So we can draw some forward paths in that also, in our problem also. But there is a condition along which no node is traveled more than once. If I am touching x2 and I am finding some way, and that the same way is repeating again, or the same path is again touching x2, then we can say it is a forward path. Okay, we can come to our figure. So which are the forward paths? You have to connect from x1 to x4, or you have to connect x1 to x4. So which are the paths? Okay, this is one path, x2, x3, x4, x4, because no node is repeating twice, and all the direction are successive arrow marks. So it is a forward path. Can you say one more forward path? Or I don't know, it is one or two or three? You can check. Okay, so please suggest one forward path. I will tell like this: from x1, x2, x4. As there is 2 x4, you have to write only one x4, because these two are identical itself. You have to say x4, don't say x4, x4. Okay, so x1, x2, x4, that is also a path. For specifying path, you have to specify the gain. So if you want to specify the path x1, x2, x4, you have to say a12 into a24 into 1. As it is 1, it does not make any change. So what is the gain of first forward path? That is x1, x2, x3, x4. That is the path's name. You just specify the path's gain. The gain of that forward path is a12, a23, a34. Will a44 comes? I am asking like this. Sorry. Okay. a12, a23, a34. Will a44 also come in this forward path? No. Why? If you are adding a44 to the path, definitely node 4 is repeating twice. So you cannot add a44. And one more question. Is it a path? Like this, then coming back like this. Is it a path? No, because node 3 will repeat twice. Not only node 3, node 4 also repeats twice. So this is the definition of forward path. It should start from input node and it should end from output node, and no node should repeats or touches twice while you are traveling through the path. Okay. Here x4 is the output node. I am reading the green line. Here x4 is the output node. So which are the paths and what are the corresponding gain? x1, x2, x3, x4, that is one path. I have drawn that path here also, x1, x2, x3, x4. While specifying the path, I just eliminated that loops and all. I just draw that path alone, and the gain of that path is a12, a23, a34, and this is the second path, x1, x2, x4, and gain of that path is a12 into a24. So these are the two forward paths. Now we are defining loop. A loop is one which starts and terminates at the same point along which no node is traveled more than once. So loop is not like a forward path. Forward path was a connection between input node and output node. But a loop is not like that. It starts and terminates at the same point. It's just what is the meaning of a word loop? Just looping. So a loop should start and ends at the same point, along which no node is traveled more than once. The same condition as that of in forward path. So no node should be traveled more than once. So we can we can come to the basic figure. So I will mark loops here. This is a loop A23, A32, A23, A32. That's a loop because no nodes are traveling twice. If you are starting from x2, x3 back to x2, loop is over. And will you tell one other loop? Yes, A34 into A43. You can see here. A34 into A43. The arrow mark is also very important. The direction of arrow mark should be successive, not like this. Then it will not make a loop. Okay, so you got two loops. Can you mark another loop? Yeah, like this. It's a loop. I will repeat once more. Start from x2, A24, A43, A32. All the arrow mark directions are successive or consecutive directions, and the loop gain is A24, A43, A32. Is there any other loop inside this figure? Please check. Yeah, here you can see it is a simple loop A44 because it starts at x4 and ends at x4. That is also a loop. So how many loops you got? You got 4 loops. Let me ask one thing. So these are the loops x3, x4, x3. The name of the loops and name of the path is not that much important. You have to always specify the gains in name of A3. If in a problem, it may not be like A34, A43, etc. It may be value 5, 6. Such values may also given. Anyhow, the nodes names is not that much important. It is just an indication. X3, X4, X3 means you can easily spot that path. That all. But for you, loop gain is very important. So first loop is there. Second loop x2, x3, x2, that is also drawn there, and the gain is A23, A32. And the third loop is x4 and its gain is A44, that is also drawn there. And the fourth loop was x2, x4, x3, x2 and its gain is A24, A43, A32. That path is also drawn there. Okay. Now I am asking a question here. A24, A34, A23. Is it a loop? So we can see it in the main figure. Then it is very clear for you. A24, A34, A23. Is the loop? No, because the direction of A24 and A34 are just opposite. So it will not give a successive direction, or it will not give a unidirectional flow. So it is not a loop. No, because direction does not provide a successive path. The second part of this video, in this video we are organizing the total content as two parts. In the first part, we detailedly discussed about what was the arrangement of a signal flow graph, how we can draw a signal flow graph from mathematical equation. Even though that is not that much important, that for your university exams, it will be never asked to draw a signal flow graph from a set of equation. You may given with some specific signal flow graph, and you have to find transfer function of that graph. That is the case. So don't worry how if you are facing some difficulty with drawing that signal flow graph, it's not that much important. But you should be very careful about identifying forward path, identifying the loops, and how to find the gain of those loops, all those things. So anyhow, in Mason's gain formula, you may be always using the gain terms. That is, if in the previous case, okay, I will show you. Here you can see it is node x3, x4. So the loop is named as x3, x4, x3 because loop starts from one point and ends on the same point. So the loop is named as x3, x4 and x3. But according to Mason's gain formula, you don't need to worry about the name x3, x4, etc. You have to be only very clear about the gain values. The gain value of that particular loop is A34 into A43. Where A34 is, this is the gain A34. This lies between the loop node x3 and x4, and this is the gain A43 that lies between the node x4 and x3. So the total gain of that loop is A34 into A43. So that is the case. In Mason's gain formula, you have to already always specify in terms of gains. You don't need to be you don't need to suppose to specify in terms of nodes, but you should know what is the node equation and what is the corresponding gain. The node x1, x2, x3, such things we are only using to denote which is the path. For specifying the path, it is the better way. You have to specify the name of those nodes. Even it is path, for let it be a forward path or let it be a loop, whatever it may be. Whenever you are specifying the names, you can say like x3, x4, x3 in terms of those nodes. But while using in equations or while applying Mason's gain formula, you are not permitted to use those names of those loops. You have to specify the gain value. For example, in problem, the gain value will not be like this A34, A43. It will be some numerical values like 5, 10, etc. So, suppose for example, in this case, if A34 is given as 5 and A43 is given as 2, what will be the loop gain of that particular path? Path name is same, x3, x4, x3. What will be the total loop gain of that particular path? You have to multiply A34 and A43. That is, you have to multiply 5 and 2. So the loop gain is 10. Like that. In problem, you have to directly substitute the loop gains and you have to find the value. Okay, it will be clear while doing problems. Now, Mason's gain formula. So, Mason's gain formula is used for finding transfer functions based on path gain techniques. If a problem is oriented in such a way that path gain is given and some nodes are marked like we seen in the first slide, not first slide, we seen in the drawing of a signal flow graph. In that case, you can directly use Mason's gain formula. So, while coming to the details, you can identify in which problems you can apply Mason's gain formula or not. So, transfer function is nothing but output by input. But this is the case. This formula is applicable only between output node and input node. It is written in the red ink. It is applicable only between output node and input node. So, in our case, we already know that x1 is the input node because from x1 all the signal are radiating towards outside. Only no arrow marks are coming towards x1. All arrow marks are going from x1 to the other nodes. So x1 is a input node. But by looking to other nodes, we can see that all the other nodes are not output nodes and not input nodes, because while considering x2, x3, x4, all the nodes are receiving some input arrows and sending some signals towards the output direction also. Both directions are linked with each node. We can see that here. We can take the first. Okay, let's see x2. For x2, A12 is coming towards x2 and A24 is going away from x2. So we cannot say x2 is neither a input node nor a output node. But in case of x1, it is very clear that only one arrow mark or only one path is originating and that path is going towards outside. If suppose there is 5 paths and all 5 paths are radiating towards outside, then we can say that node is a input node. But so x1 is a perfect input node, but while checking x2, x3, x4, we can see all nodes are receiving signal and sending signal. So all these nodes are not a perfect output node. So if you are asked to find x4 by x1, what you can do? x1 is okay, it is an input node, but for making x4 as an output node, you have to redraw a line like this, and that gain of that path is 1, and you have to rename it again as x4. So now you can see this x4 is having only one signal that is coming towards it. So it is a output node. What is the definition of output node? Output nodes should have all the signals coming towards it, or it should have only input signals. So now x4 is a output node. So if the problem may be like this, and you are asked to find x4 by x1. So without converting x4 to an output node, you cannot do this problem. For that, you have to redraw the problem like this. You have to redraw x4 into a new node with a branch gain of 1. Now you can find x4 by x1. Otherwise, with this condition, you cannot find x4 by x1. Okay. Now we are coming back to Mason's gain formula. Okay. So transfer function is output by input, and here I have written the equation sigma k is equal to 1 to n mk del k by k. Okay, there is one mistake. This is not n. Here also you have to write k. K is number of forward path. By mistake I have written the count variable as n. Normally we are always taking count as n. That's why this mistake happened. So in this case, normally in Mason's gain formula, I am writing as k is equal to. So you have to take k is equal to number of forward paths. K. So please correct this. Instead of n, here you have to write k. K is equal to number of forward paths. You have to write k. So first of all, whatever it may be, you don't know what is del k. Now it is perfectly blank for you. So first, you just by heart this equation. Sigma transfer function is equal to sigma k is 1 to n k is 1 to n mk del k by del. So n is total number. Okay, actually it is correct. N is total number of forward paths. If there is 5 forward paths, you have to take the total number as 5, and k is number of the particular path you are considering. Now it is okay. So if it is first forward path you are telling about, you have to write m1 del 1. If it is second path, m2 del 2. If there is n path, the last path will be mn del n. So it is a small mistake. So now it is clear. You have to take n as total number of forward paths. So equation is like this: sigma is equal to k is equal to 1 to n mk del k all divided by del. It is all divided by, actually you can draw this line up to this point, mk del k all divided by delta. Otherwise also, okay, it's better to draw all divided, and delta is applicable to the all sum. So this will be like this: sigma k is equal to 1 to n m k del k all divided by delta. Okay. Okay. Now mk is equal to gain of kth forward path. Kth means if it is first forward path, we have to write m1, that is gain of first forward path, like that. Del k is equal to value of delta. Up to the moment you don't know delta, so leave it, whatever it may be. First you have to find delta, then you have to find del k. But as per the equation, after mk I am introducing del k. Del k is value of delta non-touching on kth forward path. Okay, del k is value of delta non-touching on kth forward path. So if it is del 1, you have to find value of a particular delta which is non-relating or non-touching on first forward path. If you are finding del 2, you have to again check the value of delta which is not touching on second forward path. So now this is the question, what is delta? So delta is a particular equation, and from that equation you have to find del 1, del 2, del 3, etc. If there is 3 forward path, you have to find del 1, del 2, del 3. If there is 4 forward path, you have to find del 1, del 2, del 3 and del 4, like that. So what is del? Del is 1 minus sum of loop gains plus sum of gain product of 2 non-touching loops minus sum of gain product of 3 non-touching loops. Actually here gain product you have to add gain product, sum of gain product of 3 non-touching loops plus so on. So you have to be careful about, after first one I put a negative sign, then in bracket sum of individual loop gains. If I have 3 loops, let it be L1, L2, L3, and its gain are 1, 2, 3. It's an example. L1, L2, L3 are the 3 loops and its gain are 1, 2 and 3. So the second term inside the bracket will be sum of loop gains. So loop gains are 1, 2 and 3. So its sum will be 6. Next, sum of gain product of 2 non-touching loops. Sum of gain product of 2 non-touching loops. So in between these two we have to mark a plus. So it will be, here it is plus, initially it was minus, after here it is a plus, then after the third time you put minus, then again it is plus, like so on. After that, if there is another term like a fourth non-touching loop, you have to put minus. So what is the non-touching term? That we have to analyze based on some example, then only it will be clear. Okay, so we can take an example for that. So this is a signal flow graph. Here how many nodes are there? X1, X2, X3 and X4 and X5. Okay, there is actually 5 nodes. Okay, and let me whatever, leave the question. Find x5 by x1 and x5 by x3. 2 questions are asked. Initially I am going to do first question only, x5 by x1. So you have to find the transfer function based on x5 by x1. So which is the output node? X5 is the output node. And which is the input node as per the question? As per the question, x1 is the input node. So first of all, let us check whether it is output or not. x5, is it an output node? Yes, definitely, because only one signal is coming. 1 or 2, that is not important. How many signals, let it come, but the direction, all the signals should be coming towards x5 only. Then we can say x5 is a output node. And let us check the input node x1. Yeah, it is also a perfect input node because all the signals are going towards outside. Only the x1 is sending signals from it, or it is radiating signals towards outside. So it is an input node. So x5 by x1, for finding x5 by x1, you don't need any adjustment or practices. You have to directly take these two nodes are output node and input node. Okay, now my question, what was the definition of a forward path? A forward path should be connecting. A forward path should be connecting. Is it nearer to check? If it is nearer to check, that is in the previous slides. Anyway, a forward path channel or path is a connection from input node to output node, and the arrow mark will be successive in successive direction. And the third condition, no node should be repeated or traveled more than once. No node should be traveled or traced more than once. While you are traveling from input to output, you are not permitted to enter a node twice. All nodes should be touched by one time. You are not permitted to travel through any node more than one time. So you are not permitted to touch a node twice. That is the case. So which is the first forward path? It is the simple node forward path always. Always one node forward path will be very simple like this. This is the first forward path, x1, x2, x3, x4, x5. That is the name of path. And what will be the gain of that path? In between x1 and x2, we can see it is, in between x1 and x2 it is 1, in between x2 x3 it is d, in between x3 and x4 it is e, in between x4 and x5 it is 1. So what is the total gain of that path? It is 1 into d into e into 1. So that is dE. The gain of that path is dE. So you got first forward path. Then, anybody, which is the second forward path? If I am tracing like this, okay. If I am tracing like this, is it okay? Is it okay? No, you are not permitted to enter to this loop, because if you are traveling through this loop, you will touch the x2 twice. Is it clear? You will, this is the first time you are touching x2. Now you are again touching x2. So you are not permitted to travel through that node. You are not permitted to touch that x2 twice. Okay. So you cannot add such symbol loops or self loops in forward path. Now I am asking, is this a forward path? I will repeat once more, x1, x2, x4, x5. Is this a forward path? What do you think? What do you think? Is this a forward path or not? Yes. In that path, you are not repeating or you are not touching any nodes twice, and also direction of arrow mark is also successive or consecutive. No, the arrow marks are coming like this. Opposite directions are not assigned in anywhere in the path. So you can say x1, x2, x4, x5 is also a forward path, and the gain of that path is 1 into f into 1. So its gain is f. So you identified two forward paths here. You can see forward paths are D, E and F. So number of forward path is equal to 2 and N is equal to 2. Here also the same mistake happened. Sorry, it is N. Please correct. It is N. N is equal to 2. K is 1. K may be 1 or K may be 2 as N is equal to 2. So you can see x5 by x1 is equal to sigma k is equal to 1 to n. N is 2. 1 to 2 mk del k all divided by delta. Mk del k all divided by delta. So we know that there is only two forward paths and n is 2. So you can rewrite the equation by eliminating the sigma term, that is m1 del 1 plus m2 del 2 all divided by delta. Now it's the time for finding delta. So delta is all related to that term loop. I just refresh the definition of delta. Delta is nothing but 1 minus sum of loop gains plus sum of gain product of two non-touching loops minus sum of gain product of three non-touching loops and so on. Now you will understand what is the concept of non-touching and all. So here the loops are, in this particular question the loops are, this is one loop, this is one loop. Its name is just x2 because it is not touching any other node. It is a simple loop on x2. And here also there is a loop, a simple loop on x3. And here also there is a loop, a simple loop on x4. So the loops are named as L1, L2, L3, and its gain are, what is the gain of loop 1, L1? That is minus a. And for loop 2 the gain is minus b, and loop 3 the gain is minus c. So I think there is one more loop. Is this a loop? Is this a loop? No, because up to this point it is okay, but after this the direction of f is opposite to direction of e, so it is not a loop. So here we are having only 3 loops. I was just checking whether you are getting or not. So as these are the 3 loops, the first term, the gain of 3 loops are minus a, minus b, minus c. So L1 is equal to minus a, L2 is equal to minus b, and L3 is equal to minus c. So first term is okay. You will get 1 minus gain and 1 minus, what was that? Sum of gains of individual loops. So 1 minus in bracket minus a, minus b, minus c. That is the first term, that is clear. And second term was plus in bracket gain product of two non-touching loops. Now it is the time to identify the non-touching loops. It is very clear that all the 3 loops are non-touching. Is there any touch between minus a and minus b? No, these loops are non-touching. So you can say minus a and minus b are non-touching because you have to identify 2 non-touching loops only in the second term. What was there in bracket? Sum of gain product of 2 non-touching loops. So a and b are non-touching. Not a and b. L1 and L2 are non-touching. L2 and L3 are non-touching. L1 and L3 are non-touching. So there is 3 combinations of non-touching loops. L1 and L2 are non-touching, L2 and L3 are non-touching, and L1 and L3 are non-touching. So you will get 3 combination of non-touching loops. So what was the thing you want to find? Sum of gain product of non-touching loops. So first non-touching loops are L1, L2. So its gain product is minus a into minus b. So that will become L1, L2. L1, L2 that is equal to minus a into minus b. Minus minus will get plus, so that will be ab. And L2 into L3 that is minus b into minus c, that is bc. And L3 into L1 that is minus c into minus a, that is ca. So you got the 3 gain products. And what was there inside the bracket? Sum of gain product of non-touching loops. So gain product of 2 non-touching loops will be AB plus BC plus CA. Gain product of 2 non-touching loops will be AB plus BC plus CA. I will approach it by step. 1 minus sum of loop gains L1, L2, L3. Okay, that is anyhow for making it more understanding, I have put that names L1, L2, L3, not the gains. Okay, and in the second term, that is why it is like L1, L2, because that is written here sum of gain product of 2 non-touching loops, that is L1, L2, L2, L3 and L3, L1. Here it is L3, L1. So if I am substituting that, If I am substituting that, it will become 1, it will become 1 minus in bracket minus A minus B minus C plus gain product of two non-touching AB plus BC plus CA. For the time being, you are clear about up to this. After that, what was the third thing? Minus sum of gain product of three non-touching loops. So you have to go back to the signal flow graph and you have to check that whether there is any three non-touching loops. I think it is very clear for you that in our question there is three loops L1, L2, L3 and these three are non-touching. But there is only one combination. There is only one such combination of three non-touching loops because all the three are non-touching, and if there is one more loop like this, you will get more combination L1, L2, L4, L2, L3, L4, L1, L3, L4 like that. But as for the time, now we are having only three non-touching loops. So gain product of three non-touching loops are minus A minus B into minus C. So that will become minus ABC. You can see it here. Gain product of three non-touching loops, that is equal to L1, L2, L3, that is minus A into minus B into minus C, that is equal to minus ABC. And after that, you know, plus gain product of four non-touching loop will be there in the equation. 5 non-touching loops will be there in the equation, but there is no scope because we are having only 3 loops. So that all terms will become 0. Now you are substituting all the things here. 1 minus A minus B minus C plus AB plus BC plus CA minus of ABC. That will become plus anyhow. Minus of minus will become plus. So this is the value of delta. So finding out delta is somewhat a time consuming step. You will get some bigger thing. While doing a problem with the gain values, you are not supposed to write like this, because you have to use this equation as a basic equation, because from that you want to find delta 1, delta 2, delta 3, etc. Because if you are substituting the numerical value like 1, 2, 3 in that equation, you will get a simple delta value. But for finding delta 1, delta 2, etc., you again need to do the entire thing. Okay, don't be confused. While doing such a problem, you will clearly understand what I mean to say. So this is the next thing. What is del 1? What is del 1? Del 1 is value of delta non-touching to the first forward path. So now you are having the entire delta. And you have to compare that delta with your first forward path. And you have to eliminate all things that comes under the delta which are touching on first forward path. This you have to be very careful, and you have to invest your brain here for a while. Please think. Now you are getting a big equation of delta, and you have to check each terms whether it is touching on first forward path or not. Such terms will only come to delta 1 if there is a loop known as L1, and if L1 is touching on first forward path, then all terms of L1 will become 0. There is also a loop L2. You can see here, actually it was a mistake. Our figure was covered by the watermark. This was the straight line. That was the first forward path from x1 to x5, and there was 3 nodes, 3 loops on that. Okay, I will show you that. Okay, no drawings are given. So this is the first forward path, and all the loops are placed on that node, on that forward path. All the loops are touching on that forward path. So it is very clear that in the equation of delta 1, you have to put all L1 is equal to 0, L2 is equal to 0, L3 is equal to 0, because L1, L2, L3, all these three loops are touching on your first forward path. So that is the case. Now you have to check the equation of delta. Delta is equal to, that is the case. Now you have to verify by using this equation. Delta is equal to 1 minus L1 plus L2 plus L3. Will that term survive in delta 1 equation? No, because L1 is touching on first forward path, L2 is touching on first forward path, and L3 is touching on first forward path. So all these term will become 0. And what about this combination? L1, L2, L2, L3, L3, L1, that also all the L1, L2, L2, L3, L3, L1, all the individual loops itself are touching on the forward path. So the combination will entail L1, L2 is 0, L2, L3 is equal to 0, and L3, L1 is equal to 0. So now L1, L2, L3, that combination will also become a 0 value. Now you are substituting the entire thing here. Delta 1 is equal to 1 minus 0. Delta 1 is equal to 1 minus 0. So the value of delta 1 is equal to. So now it's time for finding the value of delta 2. Delta 2 is nothing but value of delta non-touching on second forward path. So now you are on the track. You already found delta, and from delta you extracted the value of delta 1, and from the same delta now you are checking what is delta 2. For that you have to first visualize the particular delta second forward path, and similarly you have to visualize all the loops, and in mind you have to check whether loop L1 touching on forward path, or whether L2 is touching on that second forward path, or L3 is touching on the second forward path. So now this is the drawing is given here. This was the second forward path, and out of the three loops, two loops, that is L1 and L3, L1 and L3, these two loops are touching on that particular forward path. So wherever L1 and L3 are present, those portions will become 0. So what was delta? Initially what was delta? This is delta. This is the basic equation of delta. 1 minus will be existing. L1 plus L2 plus L3. Out of these, L1 will be 0 and L3 will be 0. Only L2 will exist. L2 is, what was the value of second loop gain? Minus b. So 1 minus b will exist. And what about the second portion? L1, L2, will it exist? No, because L1 is equal to 0. So L1, L2 will not exist. L2, L3, in that L3 is 0. So that will not exist. And L3, L1, in that both L3 and L1 are 0. So it will not exist. And what about L1, L2, L3, product gain of 3 non-touching loops? In these, L1 is 0, L3 is 0, only L2 will exist, so that will also become 0. So what are the non-zero terms? 1 will exist and L2 will exist. So 1 minus of value of L2 is minus b. 1 minus b. So the total value of delta 2 will be, here it is, 1 minus 0 minus b plus 0 minus 0 plus 0 plus 0, like so on. So the value of delta 2 is nothing but 1 plus b. Now it is the time for substituting all the obtained values in our basic equation. What was our basic equation? Sigma k is 0 to n mk del k all divided by delta. By expanding that, you will get m1 del 1 plus m2 del 2 all divided by delta. So I am substituting here. M1 is nothing but dE, and delta 1 value is 1 plus M2 second forward path's gain is F. Gain of second forward path is F, and delta we just obtained it as 1 plus B. So second term will be f into 1 plus b, and denominator is the total delta term 1 plus a plus b plus c plus ab plus bc plus ca plus abc. So this is x5 by x1. Now you are having one more question. What is x5 by x3? Actually, I am not going to solve this question, but I have added this question for giving you some information. You cannot find x5 by x3 directly because x5 and x3, in among these both, no one is a input node. x5 is not a x5 is a perfect output loop, and x3, you can check, x3 is not a perfect output loop. This is x3. Okay, anyhow, you have to consider it as an output node for the time being, like what we have did, like by drawing a straight line like that. You have to consider x3. You have to convert x3 as an output node, but even though x3 is obtained as an output node also, but x5 is not an input node. What was the basic condition of Mason's gain formula? You can apply this formula only between an output node and input node. So here the input node is, you can convert any node as output node, but you cannot convert any node as an input node. Input node is ideally only one node, that is x1. So you have to rewrite the equation in form of x1. That is x5 by x3 is nothing but x5 by x1, that you have already done. You got the answer. x5 by x1 divided by x3 by x1, that is x5 by x1 into x1 by x3. So x1 will get cancelled and you will get x5 by x3. So x3 by x1, that you can find because x3 is not a perfect output node, but you can just convert it as an output node by assuming a gain path of unity gain, like I already explained. And x1 is an ideal input node. So x3 by x1 is output by input. So you can apply Mason's gain formula. So first you should find x5 by x3 by x1, and then you perform this operation x5 by x3 divided by x3 by x1. So this will be the final answer, x5 by x3, that is equal to answer. All the answers I have given. You have to check it as an homework because it will take some more time. Anyhow, I have explained Mason's gain formula by taking much time, and I have demonstrated the way how to apply Mason's gain formula in an analytical problem where the values are just alphabets like A12, A13 like that. But in actual problems, these gain values may be like numerical values and may not be. Such cases may also appear in exams, like alphabets may also came as gains. But anyhow, you have to expect gain values like numerical values. So we will do one more such problem, one or two problems in the next class based on Mason's gain formula. So thank you for watching. We'll meet in the next class. Thank you.